Hello, this is Weng. The title of the talk is a unified hierarchy for AI and NI through autonomous programming for general purposes. This is a journal section. The original paper has 32 pages, and I will not be able to cover the detail of the equations, rather to concentrate on concepts. Introduction. There is a sequence of topics that original editor posed, talked about human-like learning, use learned knowledge for new tasks, sound, vision, and language. AI inspires cognitive scientists, embodied representation, NI and NI collaborate. APFGP is short for autonomous programming for general purposes. Inside Skull, it's a fully automatic, autonomous, and it's skull closed throughout the life. Human is not allowed to change the parameters in the network, but outside the nature as well as teachers are the environment that indirectly change the internal representations. When symbols are not grounded, an example is Turing machine, which is symbolic, giving a task. The human will program a Turing machine, which has tapes, read, write, head, and control. Everything is to deal with symbols, input symbol, and the state is symbol. And there's transition function, start state, and input, go to next state, and next symbol that right to the tape, and head motion, right, left, and stationary. The Chomsky hierarchy is symbolic. It defines 4 levels: recursive enumerable, phrase structure for the grammar type, and automata type is Turing machine. Then going up is more restrictive, context sensitive, context free, and regular. And in terms of the machine, you have linear bounded machine, push down automata, and finite automata. For the language grammar type, you have context sensitive, context free, and regular. And the regular language is most restrictive. Recursive enumerable is more general, but still not natural language. And the context-free grammar, for example, is that on the left side, you have only one variable, and context-sensitive, you can have 2 or more, where the variable must combine together to provide a context to generate the right side. The limitation is that it's a symbolic system, and when the symbols are falsely grounded, example is that some computer vision systems that use sensors, so in that way it's grounded, but falsely grounded in the sense that symbols are not grounded. So ImageNet example include zebra type, but it does not allow similar looking striped shirts. When neural networks are not grounded, where it uses neural networks but do not take the natural input. One example is a recurrent network for Turing machine by Hava Siegelman, where input symbolic, where there's data here, there's activation where 1 means that data is active. When the neural networks are falsely grounded, it has like CNN, deep learning network, where there is a potential controversial fraud, PSUTS, which means post-selection using test set, where you choose a network with a particular type of parameters and random weights using test set. And although the random weight set may be a search based on a validation set, but the actual final selection network is based on test set. So I use that acronym PSUTS as a flaw. And there are 2 types of flaws. Where human look at the solution and to select parameters. And a machine, PSUTS, machine randomly search weights and maybe search around the grid for hyperparameters. The example include the SOM, CNN, SVM, LTSM. And so far as I know, it's only the Perceptron and DN are the two networks that do not use any PSUTS. The Perceptron is the early network that's grounded, has 7 unique features. One is using 3D objects cluttered. Second is detection recognition together that deal with scales and strides. Number 3 is large scale 3D object for deep matching, not a single matching. And also do subsampling, position blurring, max blurring, and segmentation. AMD is going beyond the pattern recognition we discussed earlier. There is a workshop on developed learning, year 2000, funded by NSF and DARPA. And after that, there is a policy forum paper appeared in Science by 7 co-authors and coined the name called Autonomous Mental Development. Later on, is a genome-like program called EN, and it's very short, only 2-page long, but it's general purposes. And later, there is a conference series called ICDL. First ICDL is the Development and Learning Workshop. That later on is called ICDL-EpiRob. There is also a MD technical committee, and IEEE transaction on IMD appeared in 2009. Now it's IEEE transaction on CDS. And there is a experimental system where what network from 1 to 9. And now we have APFGP. Now, in order to get a little bit what do we mean by FPFGP, we have a final automata. If we output a state, then it's an agent FA. So the state can represent everything like actions, tasks, context, goals. For Turing machine, and it has 3 components: a tape, bearing symbols, and a transition with a state, then read write head. Universal Turing machine is basically the same as traditional Turing machine, except that instead of given task with a special purpose, the UTM here, Universal Turing machine, where the user write a program and the data that program applied to, the machine system was written by a general computer. That computer will simulate the program and the data because it's any program, that's why it's a general purposes called UTM. The control of a Turing machine is FA, that's new. Basically it proved with some manipulation, it proved that actually the control of a Turing machine is FA, proved in 2015. Theorem here in this particular paper proved that law in brains are special cases of sensory motor data. So everything is sensory motor data. There's no symbols at all in terms of law, in terms of meaning. GENISEMA is an acronym for 8 properties: G for grounded, E for emergent, M for natural representation, I for incremental, S for skull closed, A for attentive, M for motivated, including emotions, A for abstract. A little bit about the transition from symbol, which is state and sigma, to the new symbol, new input. We make Q to be pattern emergent, can be taught or emergent, and input sigma becomes images. Then you add internal representation. The time 0, 1, 2, you can see that all the connection from left column to right column. Then it's a highly recursive, going up and down, but the network is very clear in terms of concept. It's unfolding in time. Unified hierarchy is unified sensory modality, motor modalities, internal representation. This XYZ mechanism can cut across scales, cascade, and nested. And this unified hierarchy as a graphical representation of the each neuron has 6 fields in general. Then there is a XYZ mechanism embedded everywhere, highly recurrent For the experiment, we have vision, we have stereo cameras, GPS with long-term goal, but local motion determined by vision and which is not consistent always with the goal. Audition, we learn incrementally sound. For language, we learn language using English and French bilingual environment. Conclusion is that the laws, for example, semantics are treated by DNA as special cases of data. Basically, everything is data. And meaning emerge as actions through APFGP, and the wide acceptance of APFGP for natural intelligence may take many years because the natural intelligence discipline, not many people are familiar with automata theory and the network. And in fact, the greatest enemy is our own washed brain. We're not very convenient to move on to a new discipline. Thank you very much.